to the lab using the Terraform console. In this lab, let us understand how the Terraform console runs and try the cider function that we have been talking about so far. Let's get started. Let us run the command Terraform console. So let us take this prefix. So first let's look at the function. So this is the function that we wanted to try. The first argument is a prefix. The prefix value is 10.00/16. So this is the first argument. Second argument is number 2. So which is the cider size for the subnet. And the third argument is index. So this is 0. Now if you see, we'll get 10.00/18. So if you go to the web page where we are calculating the subnet sizes, so the first index is basically 10.00/18. So this is exactly what we got. Okay. Now if I change the parameter to 1 for the last one, it will be 64.0. This is the second one. Okay. Now similarly, if I do it for the third one, which is the second index, it will be 128.0. Now the last one will be 3, 0 to 3. So it will be 192.0/18. This is exactly what we have. Now beyond that, there is no possibility for any subnets because this is the max we have, right? We are dividing the 65K IPs into 16K IPs 4 times. Now if I simply provide one more argument, one more value, which is 4, you will get an error. Call to function cidrsubnet failed. Prefix extension of 2 does not accommodate a subnet number 4, right? So that means a max of 3 only. That is the 2 to the power of this value. Okay, so this is how you can quickly verify using the Terraform console. Okay, now in the next lab, we will be showing a code how to generate this dynamically. Now let us look at the one more lab, which is the Terraform code to dynamically create the subnets from a given cider block and a size. Let's proceed further. So let's exit from this Terraform console. Now I'm this folder. This is the code I'm talking about. Let us look at the variables first. We have created some variables for the cider size and the number of edges to consider. So how many subnets we need to create and how many edges, and the private subnet cider size, which is 18 for this example. Public subnet size is 24. So then the database subnet size is 26 and private subnet for the control plane is 28. So why did I take this number? For example, given the size of the initial VPC, which is 10.00/16, there will be 65,000 IPs. Okay. Now, if I have to create the subnets for the maximum possible load, so I can create 3 subnets of size /18. So /18 means 16,000 IPs. So if you look at the page where we are creating the subnets, so each subnet can have 16,000 IPs. Similarly, for the public subnet, I'm creating a /24, which is 256 IPs. So the 256 IPs should come from the fourth subnet because first 3 subnets are already taken care because the number of edges I'm considering is 3. Okay. Now for database, I'm taking a size of /26, which is 64 IPs, and 64 IPs times 3 subnets, right? It will be 180, odd IPs. And similarly, I'm creating a separate subnet for the control plane. It's always a good idea to have a dedicated small size private subnets for the control plane just to keep the control plane API server ENIs, cross account ENIs. So we are creating /28 means 16 IPs times 3, 48 IPs. So in a VPC where the size is very small, And if you use the same subnets for the worker nodes and the pods and the control plane, it may be challenging to upgrade the control plane in future because all the IPs are already taken care by the nodes and the pods. So the control plane will not have any IPs to, for any upgrade, scale, things like that. So it's a good idea to dedicatedly allocate a small set of private subnets just for the control plane connectivity between the data plane, right? Between the data plane and the control plane rather. So let us go to the code, what we're trying to do here. Now, before I go to the code, let me first show you how we wanted to divide. So there are three subnets, which is /18. Now the fourth one I will divide further. So I'm dividing the 16,000 IPs into two more, 8,000, 8,000. I don't need this much of a size. Then I'll divide further, 4,000. And if you look at the size of the private public subnets, it is the next big size is basically /24, which is 256 IPs. So I need only 256 IPs. So I will further divide this. Okay. Now this is where I got one subnet of size /24, which is 256 IPs. This is the second one, and one more I need. So since we have three edges, so I will take three subnets of size /254. Sorry, /24, which is 256 IPs. So this is the public subnets and followed by the data plane subnets. These subnets will be where the parts and the nodes can be scheduled. Okay. Now the next biggest size is basically the /26, which is the database subnets. Now it's always a better idea to create the subnet from top to bottom. The highest size first, and the next highest size next, and the next highest size basically the database, which is 16. So in this particular CIDR block, I wanted to create subnets for the database of size as /26, right? So I'll create this further. I will divide this further. So here I see one /26. So I need three such subnets for the database. So these are the IP subnets for the database. Now the fourth one is basically for the control plane, which is /28, means 16 IPs. So I need /28. Here I have /26. So this has 62 IPs, and all I need is 16 times 3, 48 IPs. So I can divide this 62 subnet into further small subnets. So this is the /28 subnets, 1, 2, 3. Now if you see, so many other IPs are already available for us for any future purpose. So from top to bottom, first we created three subnets of size data plane. Worker nodes and the pods can be hosted here. The next three subnets are the public subnets for the load balancers, ingress controllers. And the next three subnets of the databases, this is where the database will be creating the ENIs to connect to the VPC resources. The next three subnets will be the control plane connectivity between the data plane and the control plane. So the remaining all of these IPs are spare. So for any other purpose, you can leverage. For example, if you want to have some Bastion host or some self-managed databases or any other purpose, you can leverage these IPs in the future. Now let us look at the code to generate this. Okay. Now what I did is I kind of created a small logic, some kind of an algorithm to divide this accordingly. So first I'll start with the number of subnets. So the data.aws availability zones will give you the number of availability zones in this particular region. So for example, US East 1, North Virginia will have 6 availability zones, but I need only 3. Now this is the max number of subnets that I'm going to create in this VPC. So I'm also creating I'm also getting the availability zones, and out of 6 availability zones I need only the first 3 availability zones. So this is the list of availability zones. Now this is the CIDR block, and I'm just splitting that, and I'm getting the last element in this array, which is the size of the CIDR block, which is /16. So if you look at the tf vars file /16, so I'm getting the size /16 here. Now the new bits one is what I'm calculating. So the new bits one, when I say, it is basically this particular second parameter. So I need to calculate this parameter. So for that, so I've taken the private subnet DP shader size. So this is basically size 18, okay, and the shader size is 16. So 18 minus 16, 2. So the new bits value will be 2 here, and the private subnet DP shader. So I'm just creating the private DP stands for data plane basically. This is where the pods and the nodes will be hosted. So this is a iterative loop. So out of the three subnets, three edges, I'm creating three subnets. So I'm calling this function, and the k will be changing from 0, 1, 2 because there are three availability zones, and in the local dot az is 3. So the value of k will be 0, 1, 2. For every index 0, 1, 2, it will create one more subnet. So it's an array of subnets. Now I'm calculating the public subnet base. So how do I calculate this? So if I go to the this example, so let me just divide this. Now we have created three subnets. The public subnet should start from here. This is my base. Okay. Now to calculate the base, what I'm doing is I will just create one more subnet, with the with the index of 3, right? So the number of edges to consider is 3. So far we have done from 0, 1, 2. Now this is the 3. The third subnet is what I'm talking about, right? I mean the third index, which is the fourth subnet. So this is the base for the public subnets. So using this base, I have to create three more public subnets. So that is what I'm doing here. So for the public subnets, I have to create the new bits value. So the public shader size is 24 and the private size is basically 18. So it will be 6. So the new bits 2 will be 16 in my next function. And the k will be again 0, 1, 2. So three times it will iterate. Now similarly for the database, I have to go for the next base. So if I take this example, I'll just take three public subnets. The next subnet is basically this. So this is the base for my database. Okay. So I'm just allocating the maximum subnets first and going in that order. So once the three publics are over, this one will be for the database. So for that, again, I'm doing the same logic. I'll get the base for the database. So this is the fourth, public subnet uh, based upon this calculation, right? So that I'm using as a base. Again, I'm creating three database subnets. Okay. So this will give us, three database subnets of size slash 26. Now the base for the control plane subnets will be the fourth one. So it will be this particular one. Okay. So this one will be available through this base. Same logic I'm applying. Now for that, for creating the private subnets, again I'm using the sizing. So the private subnets size is 28 and the database size is 26. So the difference is 2. So that will go here. So again I'm creating 3. So with that we will be getting three more subnets of size slash 26, 28. So these are the three subnets for the control plane. Okay, so this is the logic. You can apply this logic to any other configuration. All you need to do is change the VPC shader size and change the sizes for the individual subnet size. How much of size you need for each of the subnets. So this is important. I'm not using the secondary shader blocks for now. This we will use in a different use case, but for now let us proceed. So with this, what I will do is I'll simply do Terraform init in this folder. I will do Terraform plan. Now finally I will do Terraform apply with auto approve option. So this is our output. Let us just validate. Let us first check the private subnets DP base. So this is the initial base. So this is our initial base. Okay, this is where we started. And the three subnets will be 0/18, 64.0/18, 128.0/18. So this is what we have created, right, in the page. So this is same as what you see in the output. Now the next big subnets is basically the data public subnets. Public subnets are of size /24. So base for this is this 192.0/18. So the next one is basically this. This is the base, and out of which we created three. So 192, 193, 194/24. So this is exactly what we saw. 192, 193, 194. So these are the public subnets. Now the base for the next subnets is the database. Database is the next highest size. So the base for them is 10.0.195.0. So /24. This is the fourth subnet for the public, right? This is the base for the next subnet. So 195/0 is basically this is the base, right? So here we are creating three database of size /26. So 195.0 same 0, 64, 128. So you will see 0, 64, 128. These are the three database subnets. So similarly, for the control plane base, it will be 195.192. So that is this basically. So out of this, we will be creating three subnets of size /28. So 192, 208, 224. So 192, 208, 224. So this is how we have created the subnets based upon the given size, right? So you can apply this logic to different VPC prefixes and different sizes of VPC and the subnets. So this will be very handy to create flexible subnet sizes in your production instead of you manually going and figuring out the the subnet sizes, right? So you can fine tune this logic if you really wanted to further customize, but I think this can be good start for you to proceed further.